when we've discussed before atomic mass, we've said that like hydrogen has a mass of 1.01. The units we've used are AMU, atomic mass units. These types of units have a slight problem with the fact that they are extremely small, which makes it very difficult to use them on an everyday basis. Is that if I measure out 7 grams of iron, is that if I want to figure out how many atoms that I have there, is that normally if you know the weight of each atom, you just would take the total weight, divide by the weight of one atom, and that would tell you how many atoms you have. But since an atomic mass unit is so small, as we said, it's roughly about the mass of one proton, basically what that means is it's very difficult to do this conversion. And so the mole is an idea that we've come up with that makes it much easier to convert from a certain amount of mass to figure out how many atoms you have there, how many molecules if you have a molecular substance. So it allows us to convert from atomic mass to number of atoms. In a sense, as we said, it's an intermediary. It's something that lets us go between the actual mass of one particular atom and the mass of some chunk of stuff that we've got sitting in front of us. A mole is basically simply an amount of stuff. It's a number. It tells you how many atoms you have here. The definition of a mole is based on a particular element. That element is carbon-12. And so in order to figure out exactly how to do this, you have to look at carbon-12. And the definition of a mole is the number of atoms in 12 grams of carbon-12. And so basically if I have 12 grams of carbon-12, that number of atoms is exactly 1 mole. And so that's sort of the technical definition of it. Now, to an approximation, we basically can say that, sort of looking at that, is that 1 mole, and the abbreviation for mole is just MOL. It's not a very useful abbreviation, but it is an abbreviation. So 1 mole of protons is roughly 1 gram. So that'll give you a general idea of what it is. So if I have 1 mole, that particular number of protons, that's 1 gram. Now, what I haven't told you is what that number is. How many carbon-12 atoms are 12 grams? How many protons are 1 gram? And that answer is roughly Avogadro's number. And Avogadro's number is this one right here, 6.022 times 10 to the 23rd power. Extremely large number. I mean, if we were to write out this number right here, like in normal notation, so 6022, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So just to sketch that out, this gives you an idea of how small atoms are. So if I just had this many atoms of hydrogen, I'd have something that weighed roughly just 1 gram, had a mass of just 1 gram. Carbon-12 we talked about before, that's pretty much what you have in your pencil lead. That is actually graphite. And so if you had 12 grams of pencil lead, it would have this many carbon atoms, 1 mole of carbon atoms, so for the most part. So that sort of gives you an idea of how small an atom is and how large a mole is. But technically, a mole is just a number. It simply is just a number of things, of objects. Now, those objects are normally, in our usage, going to be things like atoms, or molecules, or ions, things along those lines. But there's no reason a mole can't be used for other things, like donuts. We're used to using a particular number with donuts, and that's a dozen. What is a dozen? A dozen is 12. What is a mole? A mole is pretty much 6.022 times 10 to the 23rd. And so this is going to be the thing that's going to let us convert between a lot of different things in this class, and it turns out to be a very useful concept. Based on what we said, is that if 1 mole of protons is roughly 1 gram, then we can say this. We can say that 1 gram has to be equal to 1 mole of AMUs, 6.022 times 10 to the 23rd atomic mass units. Because how much does 1 proton weigh? 1 proton weighs 1 AMU. A mole protons is 1 gram. So 6.022 times 10 to the 23rd AMUs is also 1 gram. Now, we could take this and we could do another approximation. Since 6.022 times 10 to the 23rd is a mole, we could divide both sides by moles, right? And so by doing that, So we divide both sides by moles on here. We basically find that moles cancels on this side, 6.022 times 10 to the 23rd, and so we are left with 1 gram over moles, that's this guy right here, is equal to just 1 AMU. Now, equal to is probably not the term we want to use here, but they are equivalent in the sense that the number you have on your periodic table for atomic mass, so say for nitrogen 14.01, we said before that's AMUs, we can also express that in grams per mole. So we could say that hydrogen has an atomic mass of 1.01 AMU. That's a true statement, but we can also say that hydrogen has a mass of 1.01 grams per mole. And that's going to be actually an even more useful statement, because now that we know this, we can now do some conversions between grams, things we can actually measure physical stuff on your desk, to moles. And from moles, you can go to the number of particles.